Hello everyone, today I'm going to discuss about not implemented. Not implemented. This is a very important concept. If we know these concepts, then we can write our program very effectively. Not implemented is one of Python's 6 constants living in the built-in namespace. Not implemented. It's in built-in. So just remember, it's in built-in. If it is a built-in, then we don't have to import it. Means in the Python interpreter, just Python. So in my left side of the screen, this is an interpreter mode, and this is the IDE. Python. We will use Python 3.9. Yeah. So if we type not implemented, then we don't get any syntax error. Why? Because not implemented is a built-in, and the Python interpreter, when we load the Python interpreter, it actually loads all these modules not implemented. So what are the other modules which it loads? One is the none, which we already discussed in the previous video, then false, then true, then none we already discussed, ellipsis, debug. So all these are the built-ins which we don't have to import it. Python will already import. Now if we check the type of the not implemented, if you can remember, we can use type function to check the type of the built-in. It's a not implemented type, so the class is not implemented type. And let's check the IDE of not implemented. So as you can see, it returns me some number, and this is the address where the not implemented is actually residing. Not implemented is a name, so not implemented is actually a name. It is pointing to some value, and this address will be 45343222392. Can we reassign this not implemented? XYZ. Yes, not implemented can be reassigned, but I would suggest to not do that because we never required this. Now, can we reassign none? No, we cannot reassign none. It will raise a syntax error. So please remember this. Not implemented can be reassigned, none cannot be reassigned. Now, when do we use not implemented? When it should be used? Why it should be used? So not implemented is a special value. It's a special value actually, which should be returned by a function, and the function should be binary. So what do we mean by the binary? Suppose we have two variables, and whatever the operations we want to perform on these two variables, this is called binary operations. A plus B, A minus B, A divided by B, all these are binary operations. So in Python, we should use not implemented wherever the binary operations are happening. Suppose we have a function def func1 and it takes a and b, then we should use not implemented in here. So how we are going to use it? So do your operations normally. C is equal to a plus b. Now if C doesn't equal to 3, return C, else we will return not implemented. Not implemented. So like this way we can use the not implemented. But instead of this not implemented, the question might have came to your mind that we can use not implemented error. We can use an exception. So suppose, for example, we'll change the function a little bit. Def function a and b. If we are adding a plus b, then return a plus b, else raise not implemented error exception. We can do this also, but why we should not do in case of binary operation like this, we will see in the code. Now in Python, what are the binary magic functions? So magic functions, we will discuss it later, but consider for as of now, just remember magic functions we can define like this with double dunders. So what are the functions which are magic functions and which actually perform the operations on the binary? So there are equal, there are less than, there are add, there are subtract. So these are binary functions. So in this kind of functions we can use not implemented. So just remember, binary not implemented is always used in binary operations. Now let's check bool of the, now let's check the value of this binary not implemented. So as we can see, the value which not implemented is holding is true. So we can write here true. Let's write some code using not implemented. Let's see how we can make our Python code so smart using not implemented. So let's define a class A, def init a, self.a is equal to a, def eq if is instance other a, print I am from a, return true. Elif is instance other b, print I am from a and checking b, return true. Return not implemented. Now let's define another class B, def init, it's a b, self.b is equal to b, def eq if is instance other of a, print I am from B, checking A, return true. And return not implemented. Sorry, now let's instantiate these classes. A is equal to A equal to 1, B 2. Now let's print A, print A equals to B, print A, B equals to A, B, print B equals to. Now internally this got converted to A dot eq A. This will also get converted internally to A dot equals B. This got converted to B dot eq B. This got converted to B dot eq A. Now let's run this program. Okay, so now print A equals to A. So this will go to A dot equal A. A is an instance of class A. So let's go to instance of class A and then check equals. So it will print, it will check if is instance other A. So other is A, this A, and it will print I am from A. It will return true. So that's why it is printing true. Now similarly, A dot equals B, it will go to this class A, and it will execute this method. It will execute this method. First it will check. So other is an instance of class B. So if is instance other A, other is a B, B is not an instance of class A, so it will not execute this, and it will go to is instance. It will check this condition, elif condition, other is B, yes, it will satisfy the condition and will print I am from A and checking B. It will return true. Now print start. Now let's look at this print B equals to B. Since B is an instance of class B, it will call the equal method of class B. So just remember this one. So now it will go to class B's def equal method. Now other is an instance, other is actually a B instance. So this condition gets satisfied and it prints I am from B checking A, and it returns. It's very simple. Now print B equals to A, B dot equals to A. This condition, this function will get executed. Other is an instance of A. Now since if is instance other B fails because A is an instance of class A, so this condition will not get executed. So what should have happened actually? it should have returned not implemented. Actually, it returned not implemented. The execution, after not satisfying this condition, the execution went to this return not implemented. But internally, the Python interpreter knows that I have to call a dot equals to b. A dot equals to b. Now, we are not explicitly writing print a equals to b in here. We have already written this in here, but this code already got executed. But why we are getting this? Then why we are getting I am from A checking B? Because internally, when Python returns not implemented, when a function returns not implemented, then the code actually knows that I have to look vice versa also. So it will check A dot equals to B also. So it will execute this function. Now other is an instance of B. So this condition gets satisfied and it will return true. Thus you are saying that, seeing I am from A checking B, it returns true. So by this way we can use not implemented to make our code much smarter. We should not we can use, instead of not implemented, we can raise not implemented error, but if we use this not implemented error, what will happen? The code will break in here. It will not, this code will not get executed. A dot equals B will not get executed if we use raise not implemented error. So thus we want the code to make we want our code to make smarter. So this is a very important concept. Thank you. See you in my next video.